Hello, the session chair and everybody. My name is Thatpong Dangsi from Rajamangala University of Technology, Pranakon, Thailand. Today I will present my paper entitled Irrigation Management, a pilot study for automatic water level management and report system development using machine learning associated with modified images. This is the agenda. Okay, let me start from the introduction. Thailand is a country where agriculture is the main occupation of the population, especially rice farming. Thus, good irrigation management is important for this major agriculture crop. Monitoring of the water situation in many river basins in Thailand has been necessary for effective water management. Thus, the installation of a measurement system with more than 700 monitoring points with CCTV cameras across the country for gathering water level data were conducted. These data are the primary data used to ensure sufficient water supply for the agriculture sector and prevention of flooding. However, it was found that the automatic system for measurement water level cannot work effectively because there are obstructions to reading the water level at the measurement point. In order to solve this sort of issues, therefore, the machine learning technique associated with image modification technique was applied in this study. Okay, come to the second section. To conduct this research, the background knowledge about digital image processing is necessary. It is the technique that is applied for processing images and to extract or obtain the required data from the images. While the pre-processing technique known as signal processing can minimize and eliminate a few issues including noise generation and signal distortion. The process for processing images is included the image enhancement, compression, restoration, segmentation, registration, feature extraction, and selection. For this slide, it is to show the overview on machine learning. This is a sub-area of AI. Algorithms for machine learning are created to produce results depending on what they have learned from example and data. Mainly, there are three types of machine learning, consisting of supervised learning, unsupervised learning, and reinforcement learning. For related works, after conducting a survey, it was found that there are several interesting previous works. However, after surveying on those previous works with several techniques, there is no any work presents the image modification technique for performance improvement of the system. Thus, it can be a research gap for this study. This slide shows the overview on the methodology. It consists of image preparation, feature extraction, model training, and prediction. This slide shows the image preparation. See, the gray image of the stop gauge is arranged, then the straight line is added. Then the image that show water was selected before cutting some of them for image modification. This slide shows the numbers of the modified images. You can see that the station S3 shows the highest number of 2000, obtaining a lot of modified images associated with stop gauges. The feature extraction was conducted. It was to convert RGB color model into HSV model. Then the step called masking was conducted to get rid of unwanted parts. For the feature extraction, see Figure 9. The subgauge that has the main part in yellow was highlighted. Since it matches with the hue, the saturation, and the value of 15, 100, 100 to 35, 255, 255. Then the HSV image was converted into the grayscale image as shown in Figure 10. For machine learning modeling, after obtaining the grayscale images, the data of all images at the column masked by the straight line from all water level measurement stations were saved as a CSV file. Then that file was randomly selected for 70% before it was imported to the machine learning tool called PyCaret, a Python library for training the model using a regression module. The output from this process is called the weight models that can be used for predict the water level of each image in the testset. To evaluate the weight models, 30% of the data in the CSV file were applied as the testset. You can see the results as shown in Table 2. The station S2 to S6 show excellent performance since the RMSE values are less than 3, whereas the stations S1 and S7 showed the RMSE of about 5 and 14 respectively. However, the average value from all stations is 4.26, which is very good for performance evaluation. For this session, there are a few issues as follows. First, this study used modified images. It has not been used in previous works. The lowest RMSE value of 1.37 is from the station S3, whereas the highest RMSE value of about 14 is from the station S7. The difference in performance can be attributed to the number of modified images used. Since the model for S3 was trained by using 2000 images, whereas S7 was trained by using about 200 images. Third, it is possible that the error may be higher than the result in this paper if images from real situations are used for evaluation. The last issue, this is only a pilot study, so more studies are required to ensure better accuracy and reliability before implementation and use for irrigation management. For conclusion and future work, after conducting the study using machine learning techniques associated with modified images for water level management, it was found that overall the system with machine learning models can predict the water level with good performance. In particular, 5 out of 7 stations show RMSE values of less than 3. So, this pilot study demonstrates that the performance of the system is sufficient for further study before widespread for irrigation management. This slide shows the references. Thank you for attention.